Is week 18, our second week of learning about light and matter. Last week we started in with this Mr. Bean phenomenon in which we were able to see this one-way mirror. I guess that's the phenomenon, this one-way mirror phenomenon in which Mr. Bean can see his reflection shining back at him, but on the opposite side there are these investigators who are able to look through as if it's a window and see his image. We're continuing to figure out a little bit about what is going on here, and at this point you have already completed your model, and you should go ahead and take a look at that and make sure that you are able to see the feedback that was given to you by your teacher, Mr. Riley, or any classmates if any was given. We didn't get to that very much last week because computer lags, much like what are happening on my computer now, prevented this document from opening up for a lot of kids. But go ahead, take a look, and of course be fixing that up to that level 3 to get your idea as far as you are able to. But in week 18 we are learning a little bit more explicitly about the reflection of light as one of the ways in which it interacts with the world around it. Now, you are going to take a look at a Nearpod, but that's going to come a little bit later on, so be a part of this video first and foremost, please. As we are learning about light, we figure out that light actually needs a source in order to be able to see things. We have things like the sun and fire as some of the ways that humans were able to see in the earlier history, and then in the last several hundred years, electric lights have also been introduced as a means of seeing the world around us. And we can see some evidence of those electric lights just right here directly above me, and a little bit of a glow of them off and over here up in my classroom here. Light doesn't always come from one of these inauthentic sources. Sometimes it's an electronic, besides electric lights, something like a phone, a TV, a computer. Sometimes we're looking at this light source directly. In this case, we can represent that light entering our eye as a straight pathway directly from that source of light to our eyeball. But a lot of the time, it's actually indirect. Most of the time, really, in order to see these things around us, to see a chair, or to see these cabinets on the back wall, or the signs hanging up and around, boxes up on the cupboards there, usually in order to see these things, light has to go to them and then bounce off before it reaches our eye. And in this case, it allows our eyes as humans to be able to see these other things. In the Nearpod that you're going to be completing, there's just a couple of quick videos that are going to teach you a little bit about this light reflection, and hopefully it'll get you thinking about your model. So if you haven't already done so, take a quick look back at your model, remind yourself of what that looked like, and then go and do this Nearpod, which will be there to help you explore some further thinking on this. And now this will be posted here in Google Classroom, and you'll be able to find the one for your classroom, your class period. And when you open that up, let me back up a little bit. Maybe the computer will allow it. When you open this up, again, studying this Mr. Bean phenomenon, you're going to watch the first video. And this one's a little bit more of a direct instruction sort of thing. You can think about the law of reflection of light. If you want to pause the video, that's great. If you want to rewind it, or even if it's loading poorly, you can open it up in YouTube by just clicking that button down in the bottom. You'll have a couple of questions to answer on a quiz about this, just 3 short questions reviewing the big ideas that we hit. Then you're going to watch this video very quickly, which actually shows 2 individuals installing a one-way mirror. Now, there are one-way mirrors that are sold as a pre-packaged sheet of glass that is already a one-way mirror, much like you would buy a mirror at a hardware store for improving your bathroom. In this case, though, they're taking a sheet of glass that was already there and wanting to make it a little bit more of a privacy window, like you can see off on the left-hand side, so that in the office behind, people aren't able to look in unless the individuals are wanting to. And when you're finished up with that, go ahead and add some thoughts onto this sheet of observations and questions, this tack board, this pin board, if you will. There are a couple of more slides, and this is just there as an extension. You do not need to finish these. If you finished up that pin board, you are done with this Padlet. If you want to jump ahead and take a look at this simulation, you are welcome to, but we will revisit this briefly in class on day 2 of this week. And you can actually play and see how light is reflected. And you can manipulate it a little bit if you want. You can even try to measure how much light there is being reflected or transmitted or shining from the source. Again, some options there for you. So in class, of course, we discussed what did we learn in our Nearpod before jumping in and making a model as a whole class. But what are some of the big ideas? Well, we learned about reflection, and as I shared with your classmates, these specific terms, sorry that got a little crossed off there, these specific terms aren't as important in my mind personally. Now, as a scientist, the more you can use precise language, the easier it is to communicate. But instead of saying incident ray, which is 2 short words, I could also say that light that shines in from the source, and people would probably know what it is that I'm talking about. Instead of a reflected way, we could say that light that shines away from a reflective object and bounces off of it into my eyes or into whatever is perceiving it. Those are totally fine ways to describe it as well. So you don't need to memorize these particular terms as much as just know what it is. And the big things that we want to know is that as light shines in towards a reflective object, it is going to bounce off, but it doesn't bounce off unpredictably. In fact, there is this kind of center line, this normal, which would be cut straight down, perpendicular, like a plus sign, straight down from the center of this reflective object, this mirror, and that angle is going to be exactly the same on either side of it, just in the same way as if you're playing a game of pool, of billiards, that ball is always going to bounce off in that equal and opposite direction. That's one of our big ideas from this, and also a really big idea is about how light bounces off of smooth versus shiny objects.
The light rays reflecting off the mirror reach the eyes in an organized
so we can see this
way
thought.
because of the law of reflection.
I'll turn down a little bit. We can see that when light is hitting this board, it does still reflect. And you can see this even just in this space, right? From my webcam. If I don't have a mirror with me, but if I have a shiny surface which is smooth and flat like my phone, mostly, a couple of cracks, a couple of air bubbles and stuff, but mostly you're able to see reflections of the light above me, or even this umbrella light that I have to illuminate myself for this video, right? Light is reflecting evenly across it because each and every ray is moving in a predictable way and bouncing off in an equal and opposite direction, versus something like wood for a clipboard, where you should still be able to see a little bit of a glare on the wood as the light shines down, but it is bouncing off unpredictably because at a microscopic level, all of these different surfaces, there we go, at a microscopic level, all of these different surfaces have different angles. I'm going to correct that previous statement. I said it's bouncing off unpredictably. What I meant by that is that to our human eye, it seems unpredictable. Is the light going to bounce off this way? Is it going to bounce off that way or another direction? To our eye, it seems unpredictable. This light is scattering in really every direction. But actually, if we were able to zoom in with these microscopic eyes to see things at this close of a level, we would see that it is, in fact, continuing to bounce at that predictable direction, that incident ray coming in, bouncing at an equal and opposite reflected ray from normal, equal and opposite from that normal direction. Always. Even on this one here, right? We could even predict that this one might go, let's see, where might normal be from here? If I draw a perpendicular line, I can anticipate that that equal and opposite might go pretty much straight up, actually, in this direction. So we can make these assumptions. From there, we led into building our class consensus models. And while they are obviously still needing some growth as the unit goes on, largely we are coming up with the similar basic ideas that we discussed in class, but really committing to them in this whole class setting. Again, we know we need to have some source of light over Mr. Beam, and that is important to consider as we are drawing our models. However, as we explore on this, it seems like in a lot of the initial models that were created by students, they showed this reflection as being a reflection from, come out computer, as being a reflection of shining down from the light and then into Mr. Bean's eyes. And actually now we're realizing, well, that's just not true. Now we're realizing it has to go to Mr. Bean and bounce off in that reflection process in order for him to be able to see his own reflection, his own image. And the same is true for those investigators. We can see that some of the light is going through and some of the light is being reflected off as it bounces off of Mr. Bean's figure, off of his head. So at this point in the lesson, that is the end of class. All students have left to do is an exit ticket to tell me a little bit about what they learned. What are 3 things you figured out, 2 things that you were wondering about, and 1 thing that you might be a little bit confused on. Go ahead and complete that exit ticket. Review this lesson as necessary if you need to. But go ahead and keep yourself constantly curious and drop into science office hours if you ever need. One final quick reminder about this week. We do not have class on Friday. It is a teacher day. So just keep that in mind. Everything Thursday and Friday are going to be bumped back one day. The same thing is true next week because we do not have school for Martin Luther King Day. Everything is going to be bumped back one day. So we'll have class Tuesday, Wednesday, and then back to a regular schedule for Thursday, Friday. Thank you for your investment. Reach out if you have any thoughts or questions. As always, I'm here to help.